Hello student, welcome once again. So here's my YouTube channel. So as you know that we are studying mathematics. As here we will start the mathematics of the class 10th. Here real number. Starting with the first chapter, that is set with the real numbers. What is real numbers? So here is the real number. Okay, real numbers. In we will understand about the real numbers and begin with to every important properties of the integers. Okay, integers, namely the Euclid division lemma, algorithms of the fundamental theorem of arithmetics. So Euclid division lemma and algorithms. Euclid division lemma, Euclid's division lemma and algorithm. Okay, Euclid division lemma and algorithms. Here is the Euclid division lemma and algorithms. Euclid division lemma. So Euclid is finding out the Euclid division lemma tell us about the divisibility of the integers. Okay, divisibility of integers is telling us it state that any positive integers a can be divided by any other positive integers b in such a way that it leaves the remainder r where r is less than b. We may recognize this as the usual long division process. Euclid division lemma provides a stepwise procedures to compare the SCF of any two positive integers, which is known as Euclid division lemma algorithms. So first of all, we will start here the Euclid's division lemma. Okay, here is the we will start here Euclid division lemma. So here some according to Euclid division lemmas state that for any two positive integers, it states that any two positive integers any two positive integers say a small a and small b and b. Suppose that small a and small b, two in positive integers exist, two unique integers exist, two unique integers. Okay, two exist in two unique integers, say q and r's. Okay, we will say here say q, small q and small r. We will take here small q and small r. So such that a is equal to bq plus r, q plus r, such that a is equal to bq plus r, where 0 is not less or equal to r and r is not less than b. Got it? So here is the hence a is dividend where a is equal to dividend what it b divisor b divisor dividends divisor quotient, sorry divi, so r divisor q ab q is equal to quotient and r is equal to remainder. As we know further, as already know it's about it. So if we take, we can say that dividend is equal to divisor into quotient plus remainder. So we can say that dividend is equal to divisor into quotient plus remainder. Okay, divisor into quotient plus remainder. So say here is divisor into quotient plus remainder. So suppose that example, we will take the example. We shall take the example. Okay, example, suppose there 7 divided by 3, 2 just 6, 1. So here is quotient, here is remainder, this is dividend, this is divisor, and here, so these words 3 is said to be the dividend. Okay, so here we have some taken here dividend, sorry, dividend divisor. So here is the 2 quotient, 7 dividend, 3 divisor, and 1 is here that remain here said to be the remainders. So with the help of the example, we had tried to understand that which is divisor, dividend to quotient or remainder. Now further it is used according to the above formula. We can say that we can write, not to say write, that A is equal to, as a formula we written here, A is equal to BQ plus R. So here is the 7 is equal to BQ, B is here, Q is here, plus R is here. So 3 into 2 plus 1. This will always give the better performance and better results. Okay, always be. So 3 into 1 plus remainders always be, so plus 1. 3 into 2 plus 1, so it will always give you 3 into 2 6 plus 1 7. So 7 LHS RHS always be equal. So let's applications of the Euclid division lemma. Applications, we will start here. Application of Euclid's division lemma. Suppose that, so we will take the one example. Here is the example. So that every positive integer, even integers is, so that every positive even integer, every positive even integers is of the form of, 2q, and every positive integers, and that every positive odd integers, every positive odd integers is in form of 2q plus 1. Okay, is an integers. Okay, 2q, form of 2q plus 1, where q is an integers, where q is an integers. Okay, q is an integers. We will solve here, sir. Let's a and b are any two positive integers. Solutions, we will solve here. Solutions, write here solutions. Here is the solutions. On the basis of the solutions, we will try to understand about the solutions and understand that what's going on here. We will take it. Here is the questions. We have written questions. Solutions, we will take here solutions. Let's a and b be any two positive integers. A and B be any two positive integers. Okay, A B two positive integers such that A is less than A is greater than B. Okay, A will always be a greater than B. Then A we will write here. Then right here in this place. Then we know that A is equal to BQ plus R. A is equal to BQ plus R. Euclid division formula we will write here. A is equal to BQ plus R, where 0 is less than, where 0 is less or equal to R and R is less than B. Got it? So suppose that this will be equation 1. We have identify as a Euclid division lemma equation 1 on putting B is equal to 2 in equation first. On putting B is equal to 2 in equation first. In equation, this is equation first. So we will write here equation for B is equal to, we have written here to B is equal to in equation first. So is equal to 2p cube plus R. So A is equal to here 2q plus R. Got it? 2q plus R, and where 0 is equal R less than R and R is less than 2. R is less than 2. Got it? So here is the second equation. Suppose that we will here suppose it as a second equations, and R is not equal to 0, where, and we will write here, and R is R we can say that R is not equal to 0. R is not equal to 0 or 1. Got it? So R is here equal to 0 or not equal to 0 or 1. So R is equal to 0, then form equations. If suppose that when R is equal to 0, then form equation second is equal to, then form equation second equals to, we will write here second equal to R is equal to 0, then we will write here A is equal to 2q. Second equations become just like that. And which is divisible by 2? Which is divisible by 2. Got it? Which is divisible by 2, and thus every positive integers either is in the form of 2q or 2q plus 1. Thus every positive integers is in form of 2q or 2q plus 1. 2q, thus the every positive integers will always be 2q is equal to 2q plus 1. Second and 2 divisible by 2, and A is equal to 2q plus 1. It's a forward. So every positive integers will always be 2q plus 1 r, as we know that the positive integers is either even or odd. So if A is positive even, then A is of the form of 2q, and if A is negative even, A is positive odd integers, then it would be in a form of 2q plus 1. These are the proved. Okay, proved. Solved here and proved here with the help of the systematic way, one by one we have discussed here, and try to inculcate you in a best way and in a elaborate manner. We have given here statements. Okay, thank you very much for that one. Okay, bye.